So, like I had just pointed out to your classmates, I don't have a whole lot to perhaps go over today. Your vocabulary evaluations, were those handed back to you? I believe they were. Yes. Okay. So as we approach next week, Monday, we will continue to review, go over a few things, because this chapter is just so big. Tuesday, we'll go ahead and continue to review. And then, I don't know, I'll be able to make that determination, but as of right now, I would say Wednesday and Thursday of next week, which would be, let's see here, the 6th and the 7th, okay, that will have our two-part exam. Part 1 is just questions over the hand, or your note guide, or however your handout, whichever. And then part 2, there might even be 3 parts to it. I'm not quite sure, just because even when you look at the reactions, it's that, it's naming, it's all of that. Okay. But one of the things I just want to go over quickly, and that's just to refresh your memory, okay? For instance, maybe got these a little too close together. And then, I don't know, I just put these in parentheses, the plus sign, I know that's just habit. And then, okay, we'll start this again, because this was such a long time ago. What is and that's how we want it written, okay? What is everything that you can tell me about today? And like I said, you have to remember back probably about 3 weeks. Okay, that's correct. We have, I heard symmetrical and asymmetrical. Which one's which? Yep, the other way around. We have, and again, when you're communicating these, that's why I always put the in front of it, okay? Just because it's just so easy to say, this is a symmetrical reagent, okay? When you say that, you'd have to be careful and say, this is a space symmetrical reagent. Or you can say, this is the symmetrical reagent. This is the asymmetrical reagent. Okay? Why would that be important for what we're reacting these with? True. And it's not important. Just because what type of reagents do we have? Those are symmetrical as well. So is this one, but this one's asymmetrical. So how would we complete this reaction? You would think so. That's why, and maybe I said this really quick. I said, those are written how we want those to be written. Because, okay, I'm going to circle both of these. Okay? That's significant. Why? Because why would we circle this arrow? Yes, you perhaps need something, but which one? Or both of them? Or maybe neither? Just this one? Maybe. Okay? But when it comes to reacting hydrogen with alkenes, you need either heat or UV light. So therefore, we can take this off and say this will proceed, but then we'll just put HT. So then we're going from propene to what over here? Propane. Yep. So you need to have that catalyst. Now that double bond has broken. So there is our reaction. Then with this one, oh, I did. Okay. I was thinking, usually I do propene for that, and I was really thinking that, and I just kept on going, thinking, okay, I want to ask questions that is making us think, even though it wasn't a late night, it was an early morning. Is that the right way to look at it? Okay. So then this top one is complete. So what about this one then? Okay. And we want you to be aware of, you have the symmetrical compound, you have the symmetrical reagent, and will we have more than one or two products for this? It'll just be one, okay? And I think for maybe for yourselves, when you do this, okay, you're not saying that there's anything bonded to there. You're just illustrating that something can be bonded there. So that's why you wouldn't want to put a dash there, because then the carbons are overloaded. So therefore, what we're saying, okay, there was a circle up top and below, so that means a chlorine went there, and then we've got, what is that, 2,3 dichlorobutane. I think that's right. But then, what happens if we change this to that? Is that going to have a real dramatical effect on this? And the answer is no, because you're going to get the same thing. However, when we do something like that, is there going to be two products? Now, because you correctly said you get the same thing, which you would. But what happens if we add another carbon on here? Do we need to be a little more specific on this side? Yes. Yep, you have to add the other possibility. We added one carbon, so now, okay, so let's see where we could bond on the second and third. So which one of those chlorines do you want to leave alone, the top or the bottom? Okay, so then we leave that alone. Then we would say this is your hydrogen, because what type of reagent is this? It's an asymmetrical reagent. You have the symmetrical compound, the asymmetrical reagent, which then means you would have two of these products, which means now we just switch these and then do that. One gives us 2-chloropentane, the other one gives you 3-chloropentane. They form about the same rates. Then what happens up top here? That or that means the same thing. Now we have the asymmetrical compound, and then what type of reagent do we have? This is asymmetrical. Now what must you have to account for? Markovnikov's rule. That's right. Okay. Which then means you have just a major and a minor product. So on the second one, this one, is that the major or the minor, do you think? That is the minor product, okay? So in short, what happens is if we make this the major product, we do that. The hydrogen here goes to the carbon that had the most hydrogens already. So that was this one. So we'll just do that. Then we'll circle this one and say this is where that hydrogen went. That's where the OH went. That's the major. Then you just flip-flop the other two to give you your minor product. Okay? So I want to make sure that I say what I mean what I say. Is that something like that? Said, I don't want to be rambling on and on and on and on. Otherwise, pretty soon it sounds like McGurkin. Like, have you ever seen Jim Carrey? I think it's Bruce Almighty, right? Have you ever heard of that before? Isn't that where he's sitting at the keyboard and he makes the guy go blah 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 blah. So pretty soon, sometimes I think if I keep talking like that, that's probably what you're hearing. Blah 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 blah. Sorry. Okay, sorry. I better. Okay, moving on. So what we want to focus in on next week, okay, is something that we haven't seen yet. We'll be in familiar territory when we're looking at these aromatics, okay. What we want to discuss, okay, is, okay, what happens if we're going to chlorinate this, okay. We're familiar with that, provided we have a catalyst here, and we'll just throw in some nickel chloride. But then what happens if we do that? Okay, so that's something. Well, yes, you would, but what we're getting at here, okay, is typically when we look at this, does this reaction proceed? Yes, it does. So we've chlorinated our benzene ring, okay? So then we put chlorine on here. But since we've got that, okay, it doesn't necessarily just stop there. You mean at the right here? Yes, you could, but what we're talking about here, when this is in excess, you're going to start adding more chlorines on this ring. But it has to be done in a specific manner, just because this is in excess. But we will cover that when we all get back here next week, because I'm starting to feel the, okay, so it's Bruce Almighty. It's got Jim Carrey, and then from The Office. Isn't that Gru's voice too? Steve. Oh, why can't I think of his name all of a sudden? Steve. Say that again? Yeah, Steve Carell. So he's the one that's sitting behind the desk there where Jim Carrey's character is like, blah, 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 blah. So, isn't Steve Carell, isn't that the voice of Gru? Yes, okay. So you can kind of see the interconnection here, because, you know, it says that on the side. If we want to take over the world, we need our army of minions. So, yeah. All right. So I think that's probably enough for today. We will catch up to you next time.